Welcome to today's lecture. Myself, Assistant Professor Tukur Gupta from Ajay Kumar Garg Engineering College, Ghaziabad. The lecture series that I am covering is for the subject microprocessor. Code is KCS 403. I am covering first unit today, and the lecture that we will study is microprocessor architecture and operation of its components. Let's go into details. Though I have already discussed in the previous lecture what is microprocessor, let's have a technical definition for this term. Microprocessor is a programmable, clock-driven, register-based electronic device that reads instructions from a storage device, first thing is it reads instructions from the storage device, takes the data from the input unit, process the data according to the instructions and provide the result to the output unit. So, there are four processes, that is it reads the instructions from the storage device, takes the data from the input unit, the second one, process the data according to the instructions which we have stored, and it provides the result to the output unit. That is the fourth operation. Next is it is programmable. What is meant by this term? That it performs different set of operations on the data depending upon the sequence of instructions supplied by the programmer. So, it is programmable. That means it will perform the operations according to the program that we feed to the processor. That is, it is programmable. Now, what is meant by the second term? That is clock driven. As we all know that the whole task is divided into basic operations and consequently divided into precise system clock periods. That we all know. Okay. Basically, microprocessor executes instructions in a sequential order following certain steps. What are those steps? We have already discussed: fetch, decode and execute. And to correctly follow these steps, microprocessor needs to activate different components at different times. And for this activation, the microprocessor needs certain clock, and it uses the clock to decide what to do and when. That is why the term clock driven comes into picture, and we say that microprocessor is a clock driven device because it needs the clock to activate the different components at different timings and consequently to perform different operations. Another important term is register based. That means storage element here is register. Electronic device because it is made up of semiconductor technologies. It is fabricated on the chip. It is made up of from some semiconductor device, that semiconductor material, that is from the silicon or the germanium. So, that is why it is known as electronic device. Now, we have understood the term microprocessor. So, we can understand what is inside the microprocessor. So, microprocessor can be divided into three segments, that is ALU, register unit and control unit. So, ALU is this, control unit and registers. This is inside the microprocessor. Now, here input device, output device and memory units are attached from the external periphery. So, basically inside the microprocessor we are given that only three units, that is ALU, register unit and control unit. ALU is your arithmetic logic unit. Let's understand these units one by one. When we talk about the arithmetic and logic unit, in this area of microprocessor, computing functions are performed on the data. CPU performs arithmetic operations such as addition and subtraction and logic operations such as AND, OR and exclusive OR. Results are stored either in the register or in the memory or sent to the output devices. So, there are three options where the outputs can be obtained. That is, it can be stored in the register, it can be stored in the memory or it can be sent to the output device. Register unit. This area of the microprocessor contains various registers. So, what are the registers? Registers are used primarily to store the data temporarily during the execution of any program, or it can also store the final results. Some of the registers are accessible to the user through the instructions. So, this is all about the register unit. When we talk about the control unit provides the necessary timing and control signals to all the operations in the microcomputer. What are the timing and control signals? That is, which function is to be performed, whether the read operation is to be done or the write operation is to be done, memory operation is to be performed or the input output ports operation is to be performed. All these controlling signals are sent by the microprocessor. These signals controls the flow of the data between the microprocessor and peripheral devices, and these peripheral devices also includes the memory also. So, on the broader aspect, we have well understood these three terms, that is arithmetic and logic unit, register unit and control unit. Now, as we saw in the diagram, though this is the microprocessor, but the microprocessor system is made up of input device, output device as well as the memory unit. So, let us go into details of these components. Input. The input section transfers the data and instructions in the binary from the outside to the microprocessor. So, what is the input doing? Input is taking the input from the programmer and giving that input to the microprocessor. So, it includes the devices such as keyboards, teletypes, analog to digital converters. So, in this, these devices are used to send the inputs to the microprocessor. So, we can either type the inputs through the keyboards, or we can teletypes it, or we can send the input as from the output of the analog to digital converters. Typically, a microcomputer includes a keyboard as an input device. The keyboard has 16 data keys, as we all know, and some additional functional keys to perform operations such as storing data and executing programs. Now, when we talk about the output, just like the input, the output is obtained using another components like light emitting diodes, this is another device, cathode ray tubes, that is CRTs, printers, magnetic tapes or another computer. These are the output devices, or we can say these are also the storage devices where the outputs can be stored. Typically, single board computers include LEDs and 7-segment LEDs as the output devices. So, these are very popular output devices, LEDs and 7-segment LEDs, where we can infer our output, we can judge our output, we can test the output. Now, when we talk about the memories, memory stores the binary information such as instructions and data and provides that information to the microprocessor whenever necessary. To execute the programs, the microprocessor reads instructions and data from the memory and performs the computing operations in its ALU section. So, this is very important role of memory, since all the data and the codes are stored in the memory, and the microprocessor reads the instructions and data from the memory and performs the ALU operations on that data. Results are either transferred to the output section for display or stored in the memory for later use. The memory block has two sections, that is read-only memory, ROM, read or write memory, that is represented by this short form popularly known as random access memory. So, basically the read-only memory is used to store the programs and that do not need the alterations, since we cannot read and write again on this memory. The monitor program of a single board microcomputer is generally stored in the ROM. The program stored in the ROM can only be read, they cannot be altered. That is why the programs that are permanent in the system, these are stored in the ROM part. The read and the write memory, also known as the user memory or the random access memory. that is used to store the user programs and data. The information stored in this memory can be read and altered easily. So this was all about the memory. So we have to remember that memory is broadly divided into two, ROM and RAM. That is, ROM is read-only memory and RAM is random access memory. Now, another important part of this microprocessor architecture is system bus. Without the system bus, we cannot transfer our data and code from either place. The system bus is communication path between the microprocessor and the peripherals. It is nothing but a group of wires that carries the bits. So what is the bus? Bus is the group of wires carrying the data or the code or the control signals. The microcomputer bus is in many ways similar to the one-track expressway. We can say microcomputer bus carries bits between the microprocessor and only one peripheral at a time. The same bus is time shared to communicate with various peripherals also. Now, when we talk about the bus system, microcomputer or the microprocessor has three buses which carry all the information. What are those buses? Data bus, address bus and control bus. These buses connect the microprocessor, that is CPU, to each of the memory and input-output elements, so that the information, data information can flow between the CPU and any of these other elements. The buses involved in all the data transfers have functions that are described below. Let's see what are these buses all about. About the address bus, this is the unidirectional bus and it will contain the information flowing from only in one direction only, from the microprocessor to the peripheral devices. Peripheral devices can be your memory or the input-output elements. Microprocessor alone can place the logic levels on the lines of the address bus and thereby generating the different memory locations, memory addresses. Each of these addresses corresponds to various locations, memory locations, or either of the input-output elements. So when the microprocessor wants to communicate with any of these memory locations or with the input-output ports, then the microprocessor places the data corresponding that particular memory location or the input-output ports on the address bus, and hence that particular address is accessed. So what it is saying, that it places the appropriate 16-bit address code on its 16-bit address pinouts A0 to A15 and onto the address bus. These address bits are then decoded to select the desired memory location or the input-output device. In this way, the address decoding is done to select any of the memory location or the input-output ports. When we talk about the data bus, it is a bidirectional bus because the data can move from either side, either from the microprocessor to the peripheral device or to the peripheral, from the peripheral to the microprocessor. Microprocessor has got 8 data pins. It depends which microprocessor we are considering. In the 8-bit microprocessors, we are having the 8 data pins, D0 to D7, and can be either inputs or outputs depending on whether the processor is performing a read or write operation. So this is very important. When it is performing the read operation, then the ports is acting as a read port, and when it is performing the write operation, the port is acting as a write port. Now the control bus, this is the set of signals that is used to synchronize the activities of the separate microcomputer's elements. So these control signals are used to synchronize the various control and status activities. Some of these control signals, such as the read and write, are sent by the microprocessor to the other elements to tell them that what type of operation is being currently done. That is, if either the write operation is being done or the read operation is being done. Input-output elements can send the control signals to the microprocessor. An example is a rest input that of the processor, which when driven low causes the processor to reset to a particular starting. So in this way, there are various signals which are sent from the peripheral devices to the microprocessors. So, we can conclude that the microprocessor operations can be categorized under three categories, that is microprocessor initiated operations, internal data operations, and peripheral initiated operations. So, when we talk about the microprocessor initiated operations, it performs basically the four functions, that is reads data from the memory, writes data into the memory, accepts data from the input devices, and sends data to the output devices. So, these are the microprocessor initiated operations. And for performing these operations, the buses that are required are these three buses: address, data, and control bus. Now, when talking about the internal data operations, the operations internal to the data are store data, 8-bit data, perform arithmetic and logic operations, test for conditions, sequence the execution of instructions, store the data temporarily during the execution in the defined read-write memory locations called the stack. These are certain very important functions, operations, which are performed by the microprocessor and which are related to the data within the microprocessor. And again, to perform these operations, microprocessor requires registers, arithmetic logic unit, and control logic, internal buses, that is the path for information flow. Now, at last, the peripheral or externally initiated operations is yet another category. External devices or signals can initiate the following operations. What are those examples? Like reset in, all internal operations are suspended and program counter is cleared. Interrupt is another externally initiated signal, normal execution is interrupted. Ready is another signal, when it is low, the microprocessor enters into wait state used for synchronization of slow peripherals. Now, hold, when activated, microprocessor relinquishes the control buses and allows external peripherals to use them, that is the DMA transfer. So, these are the externally initiated operations. So, we can say that all the operations of the microprocessor can be categorized into three categories, that is microprocessor initiated operations, internal data operations, and peripheral initiated operations. And before that, we talked about the microprocessor architecture, and in this we studied about all these units which are shown in this diagram. So, that's all for the day. Thank you.